My name is May, and I will be talking to you about the discovery of respiratory science. Through today's project, I'm going to walk you through a lot of the really early age discoveries or theories and some of the fundamental people that have laid the groundwork for the, the study of respiration. And we're going to take a look at several of the theories that have come up along the way. First, I'd like to look at several of the things that that the respiratory system does for you to put into perspective how significant the study of respiratory is. So, what is the respiratory system? The respiratory system is basically an organ system in your body that helps you stay oxygenated. It also works on blood pH regulation. There's also some immune qualities to it, or rather reinforcing your immune system. There's a defense against infection or protection from harmful particles, and it also assists in blood circulation. All of this to maintain homeostasis. Okay, early days of discovery. Here we're going to start with Hippocrates. He was often referred to as the father of medicine, and he revolutionized how we think about illness and health. He proposed that we got sick not because of divine intervention or punishment, but because of natural factors. He came up with the four humor theory. So he believed that health was a balance of four essential fluids or humors in the body. So that would be phlegm, blood, yellow bile, and black bile. And that an imbalance of these humors was thought to cause disease. And this concept actually dominated medical thinking for several centuries. Next we have Aristotle, another fundamental figure in the development of biology. He actually helped build a significant classification system, and that's influenced research in biology and anatomy. He also viewed breathing as a part of life force and emphasized the role of the heart and lungs in sustaining life. Next we have Galen. Galen was one of the most influential figures of the history of medicine. His theories dominated medical thought for over a millennium. He actually based a lot of his research or his belief of anatomy and physiology on animal dissections, and that helped him kind of understand and learn how different organs work together, how the relationship between different organs. He also believed that air was a substance necessary for life and essential for the soul's existence. He believed that air entered the body through the lungs, mixed with blood to nourish the heart and soul. Now, although his theories of air and respiration were incorrect by modern standards, they were very important steps in the evolution of respiratory knowledge. During this period, the basic idea of breathing as vital to life was clear, but the mechanisms of respiration and the exact function of air in the body remained very speculative. It would actually take centuries before scientists would uncover the actual biochemical processes involved in respiration. Now moving on to the Middle Ages and the Enlightenment period or the Renaissance. When the Roman Empire fell, Europe entered a period where scientific progress just kind of slowed down. It didn't stop, but during the Dark Ages there was a noticeable gap and scientific development compared to earlier times. And then following that, Europe began to experience a rebirth of learning. Scholars started translating ancient scripts, and that made the knowledge of earlier civilizations much more accessible. And then that's when we really start to see the birth of modern science. I'm going to start by mentioning Leonardo da Vinci. He wasn't just a brilliant artist, he was also one of the first historical figures to look deeply at how the human body works. He didn't just study anatomy through books or old teachings, he performed dissections on human cadavers. One of his contributions was sort of in learning and understanding how our lungs work. At the time, people really thought that air was sucked into the lungs, but Leonardo came up with a much more accurate theory. He believed that sub-atmospheric pressure, basically negative pressure created when the chest expands, helps inflate the lungs, drawing air in naturally as opposed to sucking it in. He didn't really understand this or how all the moving pieces connected, but his thought process was much closer to what modern breathing actually is. Next, we're going to talk about Berzelius. Berzelius, often known as the father of modern medicine, he actually performed dissections on human bodies, and he challenged previous scientific thoughts. He questioned a lot of Galen's work and corrected a lot of mistakes Galen's teachings had. He was one of the first people to accurately draw images of the lungs and the heart. And he didn't just stop in anatomy, he also explored resuscitation techniques. And though his methods were pretty primitive by today's standard, they laid the groundwork for important advancements that we have made in cardiopulmonary resuscitation. Moving into the Renaissance era, this is where the scientific method became the primary way of understanding the world. And that's a huge thanks to earlier thinkers. Joseph Black and the discovery of carbon dioxide was crucial because it showed that air wasn't all the same. CO2 is a waste product, something our body produces naturally when we turn food into energy. This discovery opened the door in understanding that different gases are involved in breathing. Next, we're going to talk about Jacques Charles and Charles' law. Charles' law is basically that when gases are heated up, they like to expand, and when they are cooled, they shrink. And this helps us understand how gases behave when we breathe in air into our lungs. Next, we're going to talk about Thomas Beddoes and oxygen therapy. He showed us that oxygen can be used to treat illnesses, especially those affecting the lungs. This laid out groundwork for modern oxygen therapy, which is widely used today for breathing-related health issues, as well as just life-sustaining measures. We are now moving into the 19th century. Okay, the 19th century. We're going to start by talking about John Dalton, and he describes his law of partial pressure, which kind of explains how the pressure of a mixture of gases is the sum of the pressure of each individual gas. This is crucial for understanding how the gases in air behave in our lungs. It helped us understand how gases move between the air and our blood during gas exchange in our lungs. Next, we're going to talk about Thomas Graham and Graham law. Graham law basically describes the law of diffusion of gases, which explains how gases move from areas of higher concentration to lower concentration. This helps us explain how oxygen moves from the air in our lungs into our blood, and how carbon dioxide moves from our blood back to our lungs to be exhaled. And then Louis Pasteur. He advanced germ theory and suggested that diseases were a result of microorganisms, or bacteria or viruses. This actually changed how we look at infections, including respiratory infections. It led to a better understanding of diseases like pneumonia or tuberculosis, and it also laid foundation for vaccines and antibodies. Let's talk about William Roentgen and the discovery of X-rays. X-rays revolutionized the diagnosis of lung and chest diseases, such as tuberculosis or pneumonia or lung cancer. It became a crucial tool in modern medicine to visualize internal structures such as lungs. X-rays transformed the ability to see inside the lungs, allowing doctors to diagnose and treat lung diseases more efficiently. There have been several different figures that came through our history, and through their research has bettered our understanding of how the body works, and how something you may not even think about, something as simple as breathing, can greatly affect everything in your body. Thank you so much for watching, and I hope you enjoy your day. Bye bye.